Hello everyone, my name is Carlos González Lorenzo. Currently I am a postdoc research at the National University of San Agustin in Arequipa, Peru. So before my presentation, I start my presentations, I would like to thanks to the international and advisor committee of this international conference on the effects in insulating materials. And also, I welcome this initiative to carry out this international conference because of these difficult situations what we are living. However, or fortunately, we have the advantage that we can keep in touch thanks to the internet. So, before this work, after these words, I will show my presentations. So I will show my screen. Okay. Okay, I hope that you are see my presentations. Okay. Also, I signed to the committee for accept this work as oral presentations. So the title of this presentation is Thermoluminescence Properties of the Salt from LLUTA. I am Carlos González Lorenzo, and so just a minute, I need to change. Okay, this is my name, and this is my the co-authors of this work. This is National University of San Agustin, and also in collaboration with University Federal of Sao Paulo in Brazil. Okay, the contents of this work, I will first start with theoretical backgrounds, measurements equipment, after that materials and methods, results, and finally conclusions. Okay, so just a little of theoretical background. We know that dosimeters at basic and ionic crystal, among them we have the most known lithium fluoride, right? We use it for several types of radiations, like gamma or thermal neutrons. Also, aluminum oxides doped with carbon, broadly used, especially for optical luminescence, optical stimulated luminescence, OSL, optical stimulated dosimetry. Okay, we have a calcium fluoride, and also we have this type of minerals, natural minerals based in silicates, broadly studied for several authors. One of them is Professor Shigeru Watanabe. He studied, for example, Brazilian natural aquamarine, tourmaline, margalite, quartz, green quartz, blue quartz, and another authors. We have Professor Dinivicia Souza, Linda Caldas, Leticia Lucente, and others important research authors. Okay, so this work is a study of the salts, and several works has been focused in the study of these salts for different localities around the world. We have natural salt from Mediterranean Sea as a radiation symmetry, improved thermoluminescence properties of this material, also the study of thermoluminescence characteristics of salts from Israeli household salts for retrospective dosimetry, also the study of thermoluminescence characteristics of sodium chloride from India. So in this guide, I will I will talk about salt from Utah in Arequipa, Peru. Utah is a town located near to city of Arequipa in the southern regions of Peru. Okay, in this picture, I'm showing this valley. The Utah salt mines are located at the slope of these hills. And in this picture, we can see the stories, how the stories maintain in their hands stones of salt, as you can see here, of salt from Utah. Okay, materials and experiments. Several equipment has been used for these experiments, for this work. One of them is the Harsha TLD Harsha lecture number 35 about at luminescence, new materials and dating laboratory at University of San. Also, Rigaku Miniflex 300 was used for X-ray diffraction analysis. This equipment also is located at our university. Okay, our laboratory has implemented with two different furnaces. One of them is type Napraterm and the furnace type Vexters. This furnace was used for thermal handling, thermal treatment of our samples. For gamma radiations, tar from Utah were pulverized and sieved to retain grains about 90 micrometers inside. These grains were protected with aluminum foil to be radiated with radiations from cobalt-60 at our laboratory. This cobalt source is a type gammatron. Look at our laboratory used for the irradiation samples, in this case, salt from Utah. Okay, we can see different the salt of Utah in different size for different purpose. For tail measurements, we use these steel grains of about 90 micrometers inside. Okay, results. We wanted to know what is the crystal structure of our sample, right? So for this reason, we make these X-ray diffractions of the sample as received. As you can see here. Also for different thermal treatment for 400, 500, 600, 700 degrees for 30 minutes. So these X-ray diffractive patterns has been identified as halide and anhydride using the expert high-score program. Also, with a high-score program was found the quantity of these two phases on the sample. For example, as received, we have halide correspond to 69% of the sample and anhydride about 21% of the sample. Okay, and so on with the other sample. As you can see here, one important result here is about this sample with a previous thermal treatment of 400 degrees Celsius. This sample shows the most quantity of halide, about 91%, and anhydride about 90%. And for the other guys, the quantity of halide and anhydride is almost maintained at about 88% and 12%. Okay, in this figure, I show you the normality log curves of salt from Utah at several thermal handling for 30 minutes, irradiated with a gamma dose of 1 grade. In all cases, about 2 milligrams and a linear heating rate of 4 degrees Celsius per second were used. In this case, for each thermal handling, for previous thermal handling, we can see different log curves. it appeared that with increasing of thermal annealing, that this maximum TL intensity, this prominent TL peak displays or go to the left. So for this reason, I study in more detail of this behavior was done. In this case, we show that TL growth curves from salt of LLUTA at several thermal annealing for 30 minutes, but in this case, we increase in 50 degrees from 300 to 700 degrees Celsius. You can see here. So one interesting point here is the TL peak at about 269 degrees Celsius. This peak is very sensitive and also is located at high temperature peaks, which is an advantage. For example, if we have or we want to use this peak as dosimetric peaks. So for this reason, we use the behavior of this TL intensity as a function of thermal annealing treatment, as you can see here in this picture. TL intensity, so TL intensity with a thermal annealing temperature, so the TL intensity will increase with thermal annealing temperature up to about 450 degrees Celsius, but after that, the TL intensity decreases rapidly with increase of thermal annealing. So I think this TL peak is relations or has a relations with an undefect center, defect, or it will be interesting to know what center will be responsible for this TL peak. So it could be a study for the future or the next step of this study. Okay, so after we know the different TL glow curves obtained with a previous thermal treatment, we decide to study or to focus with this TL glow curve. This corresponds to the previous thermal treatment of 400 degrees for 30 minutes, as you can see here. But however, what happens if the time increases? So, for this sample, we saw that with increase of time, in thermal annealing, this TL intensity increased also. So for this reason, after a given time, we could arrive at stability of this TL intensity. For these reasons, the sample of salt of LLUTA was done a previous thermal timing of 400 degrees, but for 24 hours, with an object to reach a stability in the TL intensity obtained. So for these reasons, salt of LLUTA with a previous thermal treatment of 400 degrees for 24 hours was done. In this case, measurements was done after a storage time with the object to know the fading of the sample. In addition, a preheat of 200 degrees Celsius for 30 seconds using the same harsh equipment was done with the object to eliminate the low temperature TL peak, as you can see here, with the object to eliminate to this peak, was done a preheat using the same equipment. So we can see this TL growth curves, single curves. It appears that we have single peaks. So the fading show for this sample with this previous thermal treatment has shown a high fading. It decays about 75% in the first 173 hours. It is about 7 days. After that, no significant change has been done with a tail intensity up to 600 hours. Okay, now in order to know the dose response of this this interesting TL peak, we don't these measurements. First, TL, it is that this picture shows the TL glow curves of salt from Utah, also with a previous thermal handling of 400 degrees for 24 hours. This is a previous irradiations. After that, irradiation from 10 to 100 milligrams gamma dose. TL intensity around 245 degrees Celsius. This peak shows after irradiations as a function of gamma dose of salt from Utah, has shown in this picture. Okay, we have a linear behavior, this, and a linear fitting or the linear fit of this curve. The question of this linear fit has shown in this part. Okay. Also, we need to make more measurements with increasing dose in order to know up to what point we have this linear behavior. So in this part, we need to do more measurements and more irradiations even. Okay, conclusions. TL curve shapes from salt from Utah change for different thermal handling from 300 to 1600 degrees. For this reason, but I study more details from 300 to 45 degrees Celsius. Actually, for 300 to 500 degrees Celsius, with increasing 50 degrees, was done in order to know how this TLP intensity about this temperature increase or decrease. Okay, we know the intensity at the temperature increase from this range. After that, this TLP decreases rapidly. Sample from Utah with a thermal handling of 400 degrees Celsius for 24 hours in order to arrive or to reach a stability of the crystal structure, but however show a half fading. Fading decreased about 75% in the first 173 hours, about 7 days. After that, the intensity maintains constant with storage time. The dose response curve show a linear behavior from this range of gamma dose. The linear fit shows equations equal to correspond to this equation as you can see here. However, more radiation dose will be necessary, yes, to know up to what point the linearity could be continued. After that, sublinearity or saturations will be reached. Also, we are planning to make EPR measurements to know the center responsible for a TL peak at about 269 degrees Celsius. Additional convolution analysis will be carried out to know the kinetic parameters of the TL glow curves from salt of Utah. So this is preliminary results of these samples. Thanks for your attention. Please, if you have any question, you could send to my email. This is my institutional email, and I would like to thank my UNSA Investiga, and of course to Concitec and Banco Mundial for the financial support of this work and future works. So thanks for your attention again, and I hope that you have enjoyed this presentation. Okay, I will stop my recording. And thanks a lot again. See you.